Around 66 million years ago, a world dominated by towering dinosaurs came to an abrupt and cataclysmic end. For over 160 million years, these creatures had ruled the Earth, evolving into a spectacular variety of forms, from the ferocious Tyrannosaurus rex to the gentle, long-necked Brachiosaurus. But then, almost overnight in geological terms, they vanished. What caused such a dramatic and sudden extinction event? The answer lies in a convergence of deadly events, set in motion by forces beyond the dinosaurs' control. The most widely accepted explanation begins with a single devastating moment. A massive asteroid, roughly 10 to 12 kilometers in diameter, hurtled through space and collided with Earth. The impact site is known today as the Chicxulub crater, buried beneath the Yucatan Peninsula in Mexico. This collision unleashed an explosion equivalent to billions of atomic bombs, instantly vaporizing everything in its vicinity. Trees, animals, oceans, obliterated in seconds. The shockwave alone would have circled the globe, setting off massive earthquakes and volcanic eruptions. But the real destruction didn't end with the initial impact. The asteroid threw an enormous amount of debris into the atmosphere: molten rock, dust, and sulfur-rich particles, which blocked out sunlight for months or even years. Without sunlight, photosynthesis halted, leading to a collapse in the food chain. Plants died, and with them, the herbivorous dinosaurs that depended on them. As the plant eaters vanished, so too did the carnivores who hunted them. A domino effect of starvation swept across the globe, causing ecosystems to unravel with frightening speed. Global temperatures plummeted in what's known as an impact winter. This sudden cooling, paired with acid rain generated by vaporized sulfur mixing with water in the atmosphere, made life nearly impossible. Oceans, too, were affected. Plankton, the base of the marine food web, died off en masse, leading to widespread marine extinctions. Coral reefs collapsed. Giant marine reptiles such as mosasaurs and plesiosaurs disappeared alongside their terrestrial cousins. However, some scientists believe the asteroid wasn't acting alone. Around the same time as the impact, a massive volcanic event was underway in what is now western India. These eruptions, known as the Deccan Traps, spewed vast amounts of lava and released enormous volumes of carbon dioxide and sulfur dioxide into the air over hundreds of thousands of years. These gases would have led to severe climatic shifts, first warming the planet, then causing acid rain and ozone depletion. The timing of the Deccan Traps' peak activity coincides closely with the mass extinction, suggesting that the Earth was already under immense environmental stress when the asteroid struck. The combination of both events could have created a deadly 1-2 punch that sealed the dinosaurs' fate. But not all life died. Some animals managed to survive, especially those that were small, could burrow underground, or were able to go long periods without food. Among the survivors were early mammals, ancestors of modern-day species, including humans. Birds, too, made it through the cataclysm. In fact, scientists now recognize birds as the last living dinosaurs, descendants of a group of small theropods that managed to adapt and evolve in a rapidly changing world. The fossil record confirms the suddenness of the extinction. In rock layers marking the boundary between the Cretaceous and Paleogene periods, known as the KPG boundary, scientists find a thin, global layer of iridium, a rare element on Earth but common in asteroids. This iridium layer is often accompanied by tiny glass beads and shocked quartz, both formed under the extreme pressures of an impact. Below this boundary, fossils of diverse dinosaur species abound. Above it, they are conspicuously absent. It's a stark and haunting line in Earth's history. Yet, despite the overwhelming evidence for the asteroid hypothesis, debates and refinements continue in the scientific community. Some researchers argue that volcanic activity played a more significant role than previously thought, especially given how long-lasting and widespread the Deccan eruptions were. Others point to changes in sea levels or shifts in climate patterns that may have already been pressuring ecosystems before the asteroid struck. There is even evidence that some dinosaur populations were declining in diversity before the extinction event, although this remains contested. Regardless of the finer details, the end result is the same. The Mesozoic era came to a fiery and sudden end, ushering in the age of mammals. This mass extinction was the fifth in Earth's history, known as the Cretaceous-Paleogene extinction event. What makes it particularly fascinating is how it reshaped life on the planet. With the dinosaurs gone, mammals, once small, nocturnal creatures living in the shadows, began to diversify rapidly. Over millions of years, they evolved into the wide range of species we see today, from elephants to whales to humans. In that sense, the extinction of the dinosaurs wasn't just an end, it was also a beginning. Scientists continue to study this extinction not only to understand the past, but also to prepare for the future. The asteroid that wiped out the dinosaurs was a cosmic fluke, but it serves as a grim reminder of how fragile life can be in the face of planetary-scale disasters. Today, astronomers keep a vigilant watch on near-Earth objects that could pose a similar threat. At the same time, researchers look to the past to understand how Earth's climate and ecosystems respond to dramatic changes, offering insights into our own environmental challenges. There's something haunting about walking through a museum and standing beside the fossilized skeleton of a dinosaur, a creature that once ruled the world and then, suddenly, was gone. Their bones tell a story of unimaginable power and tragic vulnerability. They remind us that no species, no matter how dominant, is immune to the forces of nature, and they challenge us to think about the legacy we'll leave behind. Even today, clues to that ancient extinction continue to emerge from the ground. In North Dakota, paleontologists discovered a remarkable site known as Taney's, which appears to capture the very day the asteroid hit. Fossils at the site are eerily well preserved, buried in a layer of debris thought to have been deposited by the impact's tsunami-like aftermath. Fish are found with tiny glass spherules in their gills, the very particles that rained from the sky after the impact. It's a fossilized snapshot of catastrophe, a frozen moment of global trauma. So how did the dinosaurs go extinct? The simplest answer is that a rock from space, aided by volcanic fury and climatic chaos, brought an end to their reign. But the deeper truth is that their extinction was a complex interplay of cosmic chance and terrestrial upheaval. It was a perfect storm of disasters that changed the course of life on Earth forever. And in that fiery crucible of extinction, the seeds of a new world and eventually of humanity were sown.